पेयर ऑफ लीनियर इक्वेशंस के इस भाग में आपका स्वागत है। आज हम सर्टेन प्रॉब्लम्स करेंगे जो कि हमें प्रीवियस लर्निंग को और ज़्यादा प्रगाढ़ करेगा। एक क्वेश्चन लेते हैं। क्वेश्चन है, फॉर विच वैल्यू ऑफ p does the pair of equations will have a unique solution? This is the question. So how we are going to solve such a problem? Let us go back to what we have already learnt. First we have to mention what are the equations. The given equations are 4x plus py plus 8 equal to 0, 2x plus 2y plus 2 equal to 0. Let us find the solution. So for unique solution, what have we learnt? If there are two equations, a1x plus b1y plus c1 equal to 0, a2x b2y plus c2 equal to 0, then a1 upon a2 must not be equal to b1 upon b2. This is the uniqueness और यूनिक सॉल्यूशन के लिए ये कंडीशन है. So let us just put these values. So values are 4 upon 2 should not be equal to p upon 2. Okay, let us cross multiply, or we can say that 8 cannot be equal to 2p or 4 cannot be equal to p, which means that except for the 4, p can have any other values. So we can say that therefore for all values of p, for all values of p except for the given pair of equations will have a unique solution. Right? So that way we can solve such problems. Let us take one more problem. The problem says for what value of k will the following pair of linear equations have infinitely many solutions? Have infinitely many solutions. एंड इक्वेशंस कौन कौन सी हैं? के एक्स प्लस 3y माइनस के माइनस 3 इक्वल टू 0 एंड 12x प्लस के वाई माइनस के इक्वल टू 0. Infinitely many solution means they are coincident lines. So let us try. For coincident line, what is the situation or what is the condition? The condition is a1 upon a2 must be b1 upon b2, c1 upon c2, all should be equal to each other. This is the condition. Condition for infinitely many solution. Condition for infinitely many solution. So let us put the values. K upon 12 equal to 3 upon k equal to negative k minus 3 upon negative k. So what do we get? K upon 12 equal to 3 upon k equal to k minus 3 upon k. So what is our condition? So the first two gives us what condition? Let us see. This would give us k square equal to 36, or k should be plus minus 6. Now let us take these two. So from there we will get 3k should be equal to k square minus 3k, which means k square minus 6k must be 0, and from here k minus 6 is 0. So k is 0, k is 6. So which is the, now we need to take the common solution. So the common solution is 6. So we will say therefore the value of k, the value of k which satisfy both the condition, which satisfy both the conditions. कौन सी वैल्यू है? यहाँ पे +6 है, यहाँ पे +6 है. So हम we will say is k equal to 6. So if k is equal to 6, pair of linear equation has infinitely many solutions. So this kind of problems are asked in the examination. Students must practice similar questions at home. Reducible equations reducible to pair of linear equations. Let us understand the concept. Equations reducible to a pair of linear equations in two variables. Let us take a pair of equation, say 2 upon x plus 3 upon y equal to 13, 5 upon x minus 4 upon y equal to minus 2. So how do we solve such a problem? Let us assume 1 upon x as p and 1 upon y as q. So my equation will become 2p plus 3q is 13 and 5p minus 4q is equal to minus 2. Now they have become these equations have been reduced to pair of linear equations. Let us now try to solve them. So how do we do? Let us apply the method of elimination. So we multiply equation number 1 by 5. So let us make it 10p plus 15q equal to 5 times 13 is 65, and then multiply equation 2 by 2. So we shall get 10p minus 8q equal to minus 10. So what shall we do? Let us do subtraction, minus plus plus. So this would be cancelled. 15 plus 8 becomes 23q will be 65 plus 10 would be 'So there is a slight mistake here. Let us correct it. When we multiplied by 2, this came out to be negative 4. So here now it will be 69. So what will be the value of q? Q will be 69 upon 23. So 69 can be divided by 23 as 3. So q has come as 3. So what is the value of p? So we can substitute q in equation 1. So 2p plus 3 times 3, it will be 13. So 2p will be 13 minus 3 3 is 9, which is 4. So p is 4 upon 2, which is 2. So value of p was actually considered as 1 upon x, which is 2, which means value of x is 1 upon 2. Similarly, value of q was considered as 1 upon y, which is taken as 3, which means y value is 1 upon 3. So this is our solution. So like this we can solve a number of problems, similar problems. Let us take yet another problem. We can take, let us solve 5 upon x minus 1 plus 1 upon y minus 2 equal to 2. And another problem is 6 upon x minus 1 minus 3 upon y minus 2 equal to 1. To solve such problems, once again let us take 1 upon x minus 1 as p and 1 upon y minus 2 as q. So what is it that we will get? 5p plus q is 2, and then 6p minus 3q is 1. So this is equation 1, this is equation 2. So let us now solve it. We can multiply this by 3, so we will get 15p plus 3q equal to 6. And now let's add both these equations. So what shall we get? This can be cancelled. We will get what? We will get 15 plus 6 as 21p equal to 6 plus 1 will be 7, which means value of p is 7 upon 21, which is 1 upon 3. And p, what was my value of p? P was 1 upon x minus 1. So we can say 1 upon x minus 1 equal to 1 upon 3, which means x minus 1 equal to 3 and x will be 4. Similarly, the value of p can be put in any one of these equations. So what shall we get? Here we can put it in this equation itself. So 5 times 1 upon 3 plus q is equal to 2. So what's my value of q? 2 minus 5 upon 3, which is nothing but 6 minus 5 upon 3, which is 1 upon 3. And what was q? q was 1 upon y minus 2 equal to 1 upon 3, which means y minus 2 equal to 3 and y equal to 5. So what are my final answers? X is equal to 4 and y is equal to 5.